right, this is Chapter 1, Lesson 6, Scientific Notation. So, the first thing that we're going to talk about is actually the definition for scientific notation. So it says words, blank blank is when a number is written as a product of a factor and an integer to the power of 10. The factor must be greater than or equal to 1 and less than 10. In those two blanks, you're going to write scientific notation. So scientific notation is when a number is written as a product of a factor and an integer to the power of 10. So a couple of symbols we can look at. A times 10 to the nth, where 1 is less than or equal to a, but less than 10, and n is an integer. So an example, I have 425 million right here, okay? This equals 4.25 times 10 to the 8th power. So how I got that was, I started from here, and I counted 1, 2, 3, 4, 5, 6, 7, 8. So that gives me the 4.2, that's where my decimal point goes, times 10 to the 8th power. Okay. Remember, this number right here has to be between 1 and 10. Okay. So we can see that standard form, right? So here's my number, 5,326 and 6/10. Okay, I can change that number into scientific notation. Right now, this is not scientific notation because this number, 5,326, is larger than 10. So I need to rewrite it. Again, I can move my decimal, 1, 2, 3. So I moved my decimal 3 spots, 1, 2, 3, so I get 5.3266 times 10 to the 3rd power because I moved my decimal 3 spots to the left. Okay? So positive powers means that they're larger numbers. Negative powers means that they're smaller numbers. You can still get a positive or a negative exponent. So you can still do this exact same thing. Negative exponents you're going to move to the right. Positive exponents are to the left. So positive, move to the left. Negative exponents you move to the right. Okay? So positive you move to the left. Negative you move to the right. Alright, so like with everything else, there are going to be a couple of rules that we need to follow for this. So let's look at a couple. So, some rules. If the number is greater than or equal to 1, the power of 10 is blank. In that blank, you're going to write positive. So if the number is greater than or equal to 1, the power of 10 is positive. So that exponent, your exponent will be positive. If the number is between 0 and 1, the power of 10 is negative. So if the number is between 0 and 1, the power of 10 is negative. You'll have a negative exponent for that. Okay? So let's take a look at a couple of examples. So I have 4 examples here. So my first example says 5.34 times 10 to the 4th. What it wants me to do is write it in standard form. Standard form is basically I take the exponent and I make it larger. I actually write the whole number out. That's standard form versus scientific notation. So I want to write 5.34 times 10 to the 4th in standard form, which means I want to go ahead and this number, the exponent, tells me how many spots I want to move my decimal. Now, since I'm going in standard form, normally if I were writing from standard form to scientific notation, I'd be going towards the left. I want to go the opposite way, so I'm changing it back. So I have 5.34, and I want to move my decimal 4 places. 1, 2, 3, 4. Okay, well I have a couple of blanks here. In those blanks, I'm going to fill in with zeros. So I have 53,400. All right, number 2, again, I want to write it in standard form. So I have 3.27 times 10 to the negative third. So this time, because I'm going from positive, or I'm going to have negative exponents, I'm going to the left because I'm writing in standard form. So again, I just want to write my number. Okay. And I want to move my decimal 3 spaces. So 1, 2, 3. So again, I add 2 zeros here. So now I have 0.00327. Okay, so for number 3, I'm being asked to write them in scientific notation. So I have 3 is 3,725,000. Okay, so basically what I want to do is I want to figure out where it will be between 1 and 10. So I need to create this number so it's between 1 and 10. So I'm going to start here, and I'm moving to the left. So I have 1, 2, 3, 4, 5, 6. This would be a good spot to put my decimal. So I have 3.725 times 10, and I moved my decimal 1, 2, 3, 4, 5, 6 spots. The reason I put my decimal here and not between the 7 and the 2 is because 37 would be larger than 10. I want my number in front of my decimal to be smaller than 10. So make sure that it's between 1 and 10. Okay, that's where you need to put your decimal. All right, number 4, same type of thing. I have 0.000316. Okay? And I want to move my decimal so that my whole number is between 1 and 10. So I'm going to start here with my decimal. 1, 2, 3, 4. That's where I can put my decimal. So I have 3.16. I can forget all the zeros in front. Times 10, and I moved it to the right. So I moved it 4 times to the negative 4. So this was a smaller number. Remember, the number is between 0 and 1. Okay, power is going to be negative. So 3.16 times 10 to the negative 4th power. All right, there are a couple of try problems, so I want you to go ahead, try those out on your own, and when you come back, we'll go over the answers together. All right, now that you've had a chance to try out the try problems on your own, let's go over the answers together. So the first one I have is letter A. Letter A says 7.42 times 10 to the 4th. Now, I'm going from scientific notation into standard form here. Okay, so I start with writing my equation out. So I have 7.42 times 10 to the 4th. All this is telling me to do, remember this is going to be a positive, so it's going to be a larger number, okay, is move my decimal 4 places. So I go 7.42, and I'm going to move it 4 places. So I start where my decimal is, 1, 2, 3, 4. I add in my zeros where I need to. So I get 74,200. Okay, letter B. .1 times 10 to the negative 2. So again, I write my number that's in front of my power of 10. I'm negative, so it's going to be a smaller number. So I go to the left. 1, 2. I add my 0 and my decimal. So I get 0.061. You don't have to add the 0 in, but it's highly recommended. It's used as a placeholder. For letter C, I have 3.714 times 10 squared, or 10 to the 2nd power. So I'm going to write my number in front of my power of 10. And it's a bigger number because it's a positive exponent, so I'm moving to the right, and I move 2 spots. 1, 2. So this tells me it's 371 and 4 tenths. All right, letter D. Letter D, E, and F, I'm actually going from standard form into scientific notation. Okay, so I need to pay attention and make sure that I'm doing my numbers between 1 and 10. So for letter D, I have 14,140,000. So what I want to do is I want to take this number that I'm given, start from the outside, and count and see how many times I need to move my decimal over. So I start on the outside, 1, 2, 3, 4, 5, 6, 7. Remember, I need to be between 1 and 10. So this is 1.414 times 10 to the 7. Because I moved over 7 times, you forget all the zeros. You just have to write the numbers down, any number that's bigger than 0. Okay, so I get 1.414 times 10 to the 7. Letter E, I get 0.00876. So for this one, it's a smaller number, which means I'm going to have a negative exponent. So I want to start at my decimal place, and I want to count how many it would take for me to get a number between 1 and 10. So 1, 2, 3. After that, 8 will count. So this is going to be 8.76 times 10 to the negative third power. Letter F is the same thing. I have 0.114. I'm going to move my decimal place 1 over, so I get 1.14, and I only had to move over 1, so it's going to be negative 1 to the negative first power. All right, on the next page is talking about scientific notation, applying what you know. So this is when we get to really kind of have the applications for scientific notation, specifically in science. So when you're dealing with scientific notation, you can use STEM. If you could walk at a rate of 2 meters per second, it would take you 1.92 times 10 to the 8 seconds to walk to the moon. Is it more appropriate to report this time as 1.92 times 10 to the 8 seconds or 6.09 years? And explain your reasoning. So in this case, it's more appropriate to explain that as 6.09 years. Because if you're saying 1.92 times 10 to the 8 seconds, you don't really see where the transition actually is. You don't see how long that would actually take. Because you're only dealing in seconds, you're not actually dealing with a longer amount of time. Okay, so the number 1.92 times 10 to the 8 seconds is very large. So choosing a larger unit of measure is much more meaningful to the situation you're dealing with. All right, so we can refer to the table at the right. Order the countries according to the amount of money visitors spent in the United States for greatest to least. So I have a couple of, this is the amount of money that they spent. So I have Canada, India, Mexico, and the United Kingdom. So the first thing we need to do is we need to recognize that we're dealing with 10 to the 7th and 10 to the 6th. So that's actually two different amounts of numbers. So we know right off the bat that 10 to the 6th are going to be smaller numbers than 10 to the 7th, because 10 to the 7th have more numbers to them. Okay, we moved the 0 more times. So we can break them into two groups. I have my two that are 10 to the 7th, so it's Canada and the United Kingdom. And then India and Mexico are in their own little group. They're 10 to the 6th. So then I can compare those two numbers. So for 10 to the 7th, I have 1.06, which is the United Kingdom, is bigger than 1.03. So I know that United Kingdom is the largest. Then it's Canada, because they're in the 10 to the 7th category. Then in the 10 to the 6th, Mexico, 7.15, spent more money than India. So that's the order that we're going to put everything in. We have United Kingdom, Canada, Mexico, and then India. They wanted us to go from largest to smallest. All right, so there are two try-it-out problems below. I want you to go ahead, pause the video, try out the try-it problems, and when you come back, we'll go over the answers together. All right, now that you've had a chance to try out the try-it problems, let's go over the answers together. So the first one I have is G. Some of the top U.S. cities visited by overseas travelers are shown in the table. Order the cities according to the number of visitors from least to greatest. So here are my 4 cities. I have Boston, Las Vegas, Los Angeles, and the Metro DC area. So the first thing I want to do is just like the example we did previously. I want to group them together. So I have 10 to the 6th, because these are both 10 to the 6th, and Boston and the Metro DC area are 10 to the 5th. And I'm going from least to greatest, so the smallest to the biggest. So the 2 with the 5s, the 10 to the 5th and 10 to the 5th, they're going to be my 2 smaller. So I have 9.01 times 10 to the 5th and 7.21 times 10 to the 5th. And then I have Vegas, 1.3 times 10 to the 6th, and Los Angeles, 2.2 times 10 to the 6th. So I want to figure out my smallest between 7.2 and 9.01. 7.2 is smaller, so that's Boston. So Boston's first, 7.21 times 10 to the 5th. Okay. Then it's, so Boston's done. Then it's the Metro DC area. So that's that one. And then I have these two. My smaller one is 1.3, which is Las Vegas. And that's 1.3. And then my largest is Los Angeles. Okay? So it's Boston, then the Metro DC area, then Vegas, then Los Angeles. All right, for letter H, in an ocean, the seafloor moved 475 kilometers over 65 million years. Is it more appropriate to report this rate as 7.31 times 10 to the negative 5th kilometers per year or 7.31 centimeters per year? Explain your reasoning. So this gets a little bit more tricky because it's kind of based off of your opinion. But the better way to represent this is 7.31 centimeters per year. This is because the number is very small, so you're dealing with a very small number. You're dealing with a very small number, so you want to deal with a small unit as well. And centimeters is a very small unit as opposed to a kilometer. Okay, so kilometer is very large, centimeter is very small. So because you're dealing with such a small number, it makes more sense to use a smaller unit. And that is the end of Chapter 1, Lesson 6.